Yes, good evening to all. So, I am Narendra Vishwakarma, PMRF scholar at the Department of Electrical Engineering, Indian Institute of Technology, Indore. So, I will be taking today the week 5 of the Principle of Communication Systems Part 2. So, I hope my screen is visible. Okay, 1 minute. I'll share my screen. Yes, my screen is visible now. So, let's take the first problem. Consider the table shown below. So where the entry for Si and Rj denotes the probability that symbol X takes the value Si and Y variable Y will take the values Rj, and the value of the joint probability H of X is. So you have to find the value of joint entropy H of XY using the following table. So I will tell few things. So this any particular value in this table will denote the probability Pij denoted as Pij, which means that probability X will take the symbol S. Let's say this is S naught, so this will be S naught, comma Y will be R2. So it will be written as P of 0, 2. Clear? 0. Now you have to find the joint entropy Hx comma Y. First of all, I will write the formula for you. So you must have seen this, that I equal to 0, j equal to 0 to, let's say total symbols are n, so it take the value from I equal to 0 to n minus 1 for symbol x, and for symbol y 0 to n minus 1. Okay, and you can write, I will write Pij log of 2 1 upon Pij. Try to calculate the joint entropy using this formula what I have written this one, and tell the answer. So have you got any answer? You can type in the chat box. So now let's solve this problem. So in this problem, what is the value of m and n? First, that there are total 4 symbols for each source x and y. So the value will I will take 3, and j will also take 3, and that will be Pij log 2 of 1 upon Pij. Okay. So for I equal to 0, 0 means for first values S0 and R0, what is the probability? it will be P00 and it will be 1 by 8. I'm writing here h of x comma y equals to, so first it's for 0 0 symbol, the probability is 1 by 8. I will write 1 by 8 log 2 of 1 upon 1 by 8, 1 upon 1 by 8 plus plus the second symbol 0. Let's say j will be 0 and let's say I will be 0 and j will vary from written any answer 3. Okay, yes, the answer is correct. Now, so and the second one R1 is 0, so probability this will be 0, 0 plus for the third one R will be 2, that is J will be 2, so it would be 0, 2. It will be 1 by 8 log 2 of 8 plus, now I am counting the values. Similarly, we have to take all these values into account for S0, 0, 0, 1, 0, 2, like that, 0, 0, 0, 1, 0, 2, 0, 3, or S1 again, S1, 0, 1, 1, 1, 2, 1, 3, all values we have to write. So, because these are the similar values 1 by 8, 0, 1 by 8, 0, so directly we can count the values and multiply it. Okay. So how many zeros are there? 1, 2, 3, 4, 5, 6, 8 are there. So we no need to care about that, but 1 by 8. Count 1, 2, 3, 4, 5, 6, 7, 8, 8 times. So directly we can write. So directly this one, and we can write 8 times 1 by 8 log 2 of 8. So it would be log 2 of 8. That is nothing but log 2 of 2 raised to 3, and it will simplify as 3 bits. Okay. If the values are different for each entry in this table, then we have to write each and every term. Okay, like that we have written in the summation form. So we have to expand the summation and write write the write the probability term and the log term for each this one each entry. Clear? So I hope this will be clear. Any doubt in this one? Yes, any doubt in calculating the entropy of HYX, or any doubt in this table, how this table, from this table, how we can write the entropy or something, or the probability? What I have told this,
Sir, I have one doubt, sir.
yes, yes, tell me.
Sir, if it is the log base to it, if it is the log base of 24 or 30, other than the powers of 2, how can we calculate the values?
Let's say I will also solve the problems related to that, but I will tell you here only. So if you are taking log 2 of
Base
3,
2 of, it's,
yes, so directly you can write log 3 base 10 log base 2, and from calculator you have to calculate,
yeah,
or the log table.
yeah, okay, okay. That's the only way, or rather than there is no possibilities.
No, no.
Yeah, okay, sir. Thank you.
So yes, we will proceed with the next problem if there is no doubt in this problem. So problem number 2. So consider the table shown below, the previous table, where the entry for this Sij denotes the probability x equal to Si and y equal to Rg. The source entropies Hx and Hy is. You have to find the source entropies. Okay, you have to find the source entropy Hx and Hy. Previously we have the joint entropy. Now we have to find the source entropies Hx and Hy. Clear? Write the capital X and capital Y. I have mentioned capital X and capital Y. Now I will give a formula for it that you can solve. So source entropy, let's say for X I am giving, so Y you can write by yourself. So source entropy X, H of X is given as H of X equals to sigma I equal to 0 to n minus 1 probability of Si log 2 of PR of, or you can also write an expand X equal to Si, or also you can write probability X equal to Si. Yes, so first you have to find the probability X equal to Si for all I varies from 0 to m minus 1. So here m is 4, 0 to 3. So I will take 0, 1, 2 and so these probabilities are called marginal probabilities. Marginal probability for X. Probability of X and Y are called as marginal probabilities from the joint distribution. And how to find these probabilities using the joint distribution table? Yes, anyone? How to find, let's say X equal to S naught, probability X equal to S naught. How can we find? We have to find probability X equal to S1, probability X equal to S2, similarly probability X equal to, how many are there? 4 symbols are there, S3. Now it will be the sum of all the probability, these S naught. This will give you, sum of this will give you probability X equal to S naught. So it would be 1 by 8 plus 0 plus 1 by 8 plus 0. It would be 2 by 8, that is 1 by 4. Similarly, probability X equal to S1 will be equal to the sum of all these probabilities. That would be 0 plus 1 by 8 plus 0 plus 1 by 8. That is again coming out 1 by 4. Similarly for S2, you will calculate, and S3 or will be coming as 1 by 4. Okay. So these are the probabilities corresponding to each symbol S0, S1, S2, S3. Okay. And probabilities corresponding to the symbol Y equal to R0, probability Y equal to R1, probability Y equal to R2, and probability Y equal to R3 would be along this. This is R0, and the corresponding to this would be the sum of the probabilities along this column. It would be 1 by 8 plus 0 plus 1 by 8 plus 0, that would be 1 by. Similarly for R1, take a different thing. And it would be here. Here the values are same, that's why it is coming same, but it will not come same for different values of this S0 and R1 probability. So here the values are coming such a way that they are coming same. Okay, but remember it will not be same for each table. If the table is different, it would be different. All will be different means there is no such condition that all should be equal. So first thing we have to calculate the source entropies for the symbol Si. Okay. So I've already written the formula h of x equal to I equal to 1 to n minus 1 pi s of I. This one, so I am now writing, I've calculated that. Clearly I will write I equal to 0 to 3, probability that x equal to s of I log base to 1 upon probability s of, sorry, x equal to si would be, all are same. Okay, all are same, so we can directly write 4 multiplied, so we can directly write 4 multiplied by log 2, sorry, 1, that the probability of xi is nothing but 1 by 4 for all. So I've done a mistake. That would be 1 by 4 to log 2 of 1 upon 1 by 4 is 4. Directly we'll get 4 will be written as 2 raised to 2, will be 2 bit. H of x, h of x would be 2. Okay, so here first would be 2. Similarly for h of y, how can we written? Well, how can we write? So for h of y, source entropy, to write the source entropy y is h of y is sigma. Now I am writing just j. It is understood that j equal to 0 to n minus 1. So probability y equal to r of j log of 2 1 by probability y equal to r of j, jth probability. Again, we have calculated probability y of r naught, r1, r3. No? So probability r0 equal to probability of y equal to r1. All are equal. Okay, so you can write that is 1 by 4. So it would be 4 times 4 symbols are there and with equal probabilities. So we are writing like 1 by 4 log 2 of 4 upon 1 by 4, that is 4. 4 times because 4 are there and all are equal. That's why it is coming. So it will also come as 2 bits. Clear? So h of x, h of y will be clear. Once again, you will see how to calculate. For the source entropies, we have to calculate the marginal probabilities for x and y. We are calculating the marginal probabilities directly. We can calculate the source entropy by using this formula here. And how to calculate this? We can calculate this directly by using the marginal distribution table. So across S naught, we have to sum all the probabilities and we will get P of x equal to S naught, and for the second symbol, that is y equal to rj. So we will sum across all r naught. It is very simple, r naught across all r naughts. Okay, all the values we have to sum. So we'll get probabilities y equal to rjs for all j equal to 0 to 3. Clear? So yes, any doubt in this one? This problem is clear. Okay. Then we'll move to the third problem. So 8 array PAM source SA. So there is a 8 array PAM which has the source SA, which generates 8 symbols. Okay, obviously 8 array PAMs will generate 8 symbols with probabilities given as, some probabilities are given as 4 beta, 2 beta, 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 and 2 beta, 4 beta. So now to find the value of beta and source entropy H of SA. So you have to find the entropy for this source SA, where the source SA generates the symbols for 8 array PAM, 8 symbols. So clearly see that this SA will generate the 8 symbol for array PAM as, let's denote as S0, S1, S2, S3, 4, 5, 6, and S7. S7 and this is the symbol S and the probability of SI. This is SI, probability of SI. SI would be what is given as 4 beta corresponding to S naught. I am assuming this 2 beta, 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 2 beta, sorry, 2 beta, 2 beta and 4 beta. Now how to find the value of beta? Yes, any method is there or any property is there? Just tell me how to find the value of beta or any trick is there? I will give you 1 minute to solve this and 1 minute for to solve the entropy. Okay, if we find beta, then we can easily calculate the entropy. And what is the entropy of HSA? So HSA will be sigma I, where this is P of I log 2 of 1 upon Pi. Where Pi is nothing but probability that S will take, let's say some variable is S, will take S of I. So if we calculate this probability Pi, let's say this is nothing but Pi, then we can easily calculate the entropy. So first we have to calculate the value of beta here. How to calculate the value of beta? Just think. And those of you who have solved the value of beta, they can write in the chat box what is the value of beta.
Beta is 1 by 16
Beta is 1 by 16. Yes, correct, sir.
because sum of probability should be 0, should be 1.
Ah, yes, correct. We are using the total probability rule. That is, total probabilities will be 1. Very correct, sir. Now calculate the source entropy HSA. That would be very easy. So here we will use we are using the total probability rule. That is would be 1. So here we will sum all the probability, that is 4 beta plus 2 beta plus beta, nothing but 1, and all this will be 16 beta. So beta would be 1 by 16. So it is clear. Now you can form this table by substituting the value of beta and you will get the probabilities. Okay. So now I will draw that table to show you the values. That is Si. So S0, S1, S2, S3, S4, 5, 6, and 7. So Pi would be 4 beta, that is 4 by 16. 4 by 16 is 1 by 4. Clear? Then 2 by 16, 1 by 8. Then it should be 1 by 16, 1 by 16, 1 by 16, 1 by 16, and again 1 by 8 and 1 by 4. So now you have got the probabilities. Directly calculate H of SA. That would be 1 by 4 starting 1. pi, that is S naught, probability of S naught. So S equal to S naught, so it will be 1 by 4 log 2 of 1 upon 1 by 4, that is 4 plus, so it is how many times? 1 by 4 is coming 2 times, so we will multiply this one by 2 plus 1 by 8 log 2 of 8, how many times? Again 2 times plus 1 by 16 log 2 of 16, how many times? It would be 4 times. Now solving this one, right? If you are writing, so directly solve here. Also solving this one, so it would be half with 4 and 4 times it will be 1 by 4. So I'm writing, I will solve. If you have written, then I will move to the next slide. So here that would be h of SA. That would be. So you got the answer. Yes, yes, 2.75. It's correct answer. So it would be 1 by 2 log 2 of 4 plus 1 by 4 log 2 of 8 plus 1 by 4 log 2 of 16. So it would be, this will be written as 2 raised to 2, it will be written as 2 raised to 3, it will be written as 2 raised to 4. Okay, now solve log base 2, 2 raised to 4, it would be 4. And here log base 2, 2 raised to 2, it would be 2, 2 by 2 plus, it would be 3, 3 by 4 plus 4 by 4. So clearly it would be 1 plus 1 plus 2 plus 3 by 4. So by solving this one, you will solve and you will get 2.75. Okay. Have you understood the concept? Because here we have to see that the total probabilities of all the symbols will be 1. Okay, and one more thing, the one question can be coming as there are two symbols with the equal probabilities. Then the probability for the two symbols, if equal probabilities, it would be p plus p. Let's say p plus p, that would be half half. Okay, but these are 8 symbols which have unequal probabilities. Not, the probability is not equal, so we have to equate them with 1 and find the value of beta. So to find the values of the probability, then we can easily calculate the source entropy. Clear? So yes, any doubt in this one? Okay, so see this one and we'll move to the next problem, that is problem number 4. So for the same table where the entries are given as probability x equal to si and y equal to rj, what is the value of alpha? No, so this is a new table where the probabilities are not given directly like the previous slide. Directly it was given the previous problem, but here the probability is not given, it is given in terms of some constant alpha. So first we have to find the value of alpha, then we can proceed with the other things like entropies of the source and the entropies of the joint entropy and other things. So again the same rule, total probability rule. So tell me the answer. Now, this is a simple problem. We have to find the value of alpha. In the previous case, we have to find the value of beta. On the same principle, find the value of alpha here. So one thing I will write, any distribution for the probability distribution is valid if the sum of all the probability should be 1. Okay, so now here this is, let's say, Eij nothing but P of 0 1. So all the probabilities like P00, P01, P02, P03, you have to sum all the probabilities and equate it to 1. So we are summing all that. So 3 alpha, so how many 3 alphas are there? 1, 2, 3 and 4. So 4 times 3 alpha plus alpha, total 16 are there. So remaining, the 4 are there, 4 we have already taken. So now alpha, how many alpha will be there? 12. Okay, total 16 are there, so minus. So 12 into alpha, it will be equal to 1 only, which implies that would be 12 plus 12, 24 alpha. So alpha would be 24. The answer would be C. So have you given the answer? I hope this problem is clear. Problem number 4. Simple problem based on the value of how to find the value of alpha in the table, in this joint distribution table. The probabilities are not given, or in terms of some constant. So we can find the constant easily by using this rule. By using this one. Okay. So now we'll move to the problem number 5. I hope problem number 4 will be clear, or no doubt in that one. So in problem number 5, so we have the same table, but now here we have to find the value of the joint entropy Hxy. So to find the joint entropy Hxy. So four options are there. I will wait for 2 minutes for this problem, then we will proceed with the solution. So again, I will write the formula for you. So h of comma y will be sigma double summation pij log 2 of 1 by pij. Okay. This is I, this is j. So get the answer in terms of the options given here. One more thing, we have already calculated the value of alpha. So alpha is 1 by 24. Now I will modify this table according to the value of alpha. So meanwhile you solve the problem, I am modifying the table. Okay. So 3 alpha 1 by 24. So it will be 3 by 24. It will be 1 by 8. That is 1 by 24. 1 by 24. Again this is also 1 by 24. This is 1 by 8. 1 by 8. 1 by 8. Okay. Now, have you got any answer? There's no answer still. So now I will solve this problem. So it is simple only. So h of x comma y would be, so we have to sum all the individual entropies for this probability, that is one that is given here. So that is 1 by 8. So 1 by 8 log 2 of 1 upon 1 by 8, that is 8. So how many times? 1, 2, 3, 4, 4 times. That is 4 times, plus that is then the next is alpha is 1 by 24. So that is 1 by 24 log 2 of 24. How many times? It is 12 times. Simply 12 times. So now simplify that one. Now simplification is the process already. You should calculate this one 2 raised to 3. So it would be, I think, 3 by 2 plus 1 by 2 log 2 of 24. So I have all have solved up to this step. Now you have to open this logarithm. 3 by 2 plus 1 by 2 log 224 can be written as 4 into 3, sorry, 4 into 6. Okay, so 4 into 6, or in the log 3 by 2 plus log 2 of 4 half. So in the if the values are in the product of the log, then we can simplify as the sum of the logs, half log 2 of 6. That 6 also can be written as 3 into 2. So 3 plus half log 2. So it would be 2 raised to 2. So it will cancel out 3 by 2 plus 1 plus, so it is not, it cannot be further solved. So here it should be 1. Sorry, yes, 1 half. Clear? So half 3 by 2, it would be 2, 2 plus 1, 3, 3 plus half log 2 of 3. So I think it is matching with of x, y. It is which matching with the option P. 3 plus half log base 2, 3. It is simple, only you have to apply some properties of the logarithm function, and you have to get it in the form of uh, you have to solve until you got this thing, or also you can solve with the calculator. The calculator will solve this, and I will tell you what is the answer. So log of 3 divided by log of 2, that thing divided by 2, so plus 3, so it will be 3.79. If you solve by the calculator, I think it is coming as 3.79. So confirm this. We will move to the problem number 5, problem number 6 now. So this problem is clear to all, or any doubt in this one? Should I wait? Yes, sir.
So we are expanding it log of m into n, log of m plus log of n. Why we have to add the last step 1 by 2 log base 2 of 2?
This one
So
or here?
log base 2 of 4 into 6, we can represent this, actually we can consider it as log of m into n. I think so.
Hmm.
Log of m and log of n, and the last term why we have to include 1 by 2 log base 2 of 2.
This one. Actually,
Last,
this was 4 into 6.
yes,
Or you can write, or you can expand this as 4 into 3 into 2.
to 2. Okay, okay, okay,
Or,
sir.
or,
Okay.
or directly 8 into 3.
Okay.
8 into 3.
Yeah,
Because
okay.
it is a
Now I
multiple
can
of 2.
clear. Yeah, yeah, now I can clear.
Okay. 8 into 3 would be more suitable. Now problem number 6. So the same table, but here we have to find the values of marginal entropies, that is h of x and h of y. What we have, I think I have already solved this in which problem? Problem number 2. Okay, already we have seen this type of problem, but here the values, the table is different. So already you know h of x would be summation I equal to 0 to again m minus 1 probability x equal to s of I log 2 of 1 by probability x equal to si, and h of y would be summation j equal to 0 to m minus 1 probability y equal to s of j, sorry, r of j. We have taken r of j. R of j log 2 of 1 by probability y equal to r of j. Clear? So I've already told you. Now I will expand here only. I've already told you to calculate these probabilities. We have to calculate the marginal distribution of and y. So for x, probability x equal to si. So it would be S0, S1, S2, and S3. And for y, it would be probability y equal to r of j. So it would be r naught, r1, r2, and 3. So directly you can calculate sum. You can take the sum out of it. For S naught, the sum will be 3 alpha and 3 alpha, the 6 alpha. Here also 6 alpha, I think. Here 2 alpha, 3 alpha, 5 alpha, 6 alpha, and here also 6 alpha. And what is the value of alpha? We have already calculated the value of alpha is 1 by 24 in the previous problem also. That is 1 by 24. Remember that? That is alpha is 1 by 24. For the same table is same. So 1 by 24. So put here alpha 24. So 6 into 1 by 24. So it would be, I think, 1 by 4. And similarly for others, 1 by 4, 1 by 4, and 1 by 4. So it would be 1 by 4. Just I am writing, you can also directly solve, but making the table would be beneficial if the probabilities are different. Here the probability are same, so no need for this step. Directly you can calculate. But if the probabilities are different, then it will be helpful to write properly in a table the marginal densities, marginal distribution of. Now for R naught, sum this 6 alpha, again 6 alpha, 6 alpha, 6 alpha. If you put the value of alpha, then that would be same. Clear? Now calculate the value of hx and hy. Hx would be sigma p of si log 2 1 upon p of I. That is 1 by 4, 1 by 4 here. Okay, so 1 by 4 log 2 of 4, how many times? 4 times, clearly 4 times. So it would be 2 bits. Similarly, h of y would be, that is 1 by 4, 4 times. So it would be 1 by 4 log 2 of 4. We have seen that it is also equal to 2 bits. This is clear? Yes, sir. Any doubt in this one? Okay, so now there is no doubt. Then we will proceed with the last problem. Problem number 7, that is based on the condition, the entropy of Y conditioned on X. So this problem will take some time. So how to write the condition probability H of Y given X? That is nothing but the entropy of Y conditioned on X. Entropy of Y conditioned on X. So it would be sigma I equal to 1 to 0 minus 1, probability X equal to Si, and H of Y condition that X equal to Si. This is slightly some different form, so pay attention to this formula. It's slightly different from the others. It's not very direct. Previously, the previous formulas are very direct. This is not. Oh, sorry, I've done some mistake here. Once again, I will write. So it should be H of Y given sub Si should be okay. Okay, sorry. Okay, the previous formula was also correct. Actually, I was confused. So Y of given X would be sigma I equal to 1 to n minus 1, probability X equal to Si. Okay, that was correct only. H of Y given X equal to Si. So to calculate this one, we are using this formula. So pay attention, the previous formula was correct only. So from I equal to 1 to n minus 1, where X is taken value Si, and this H of Y given X of Si would be calculated by using this formula. Okay. So first we have to calculate this one. So to calculate this one, we have to calculate this probability y of probability y equal to rj given x equal to si. Okay. So to calculate this probability, that given y given x of, sorry, quickly I will solve this. So probability y equal to r0 given x of s0, because it will be vary from 0 to n minus 1. So first rj, so r0 x0, it would be probability, it is a condition probability, so we have to apply some rules of the probability, that is a condition x equal to s0 divided by probability of x equal to s0. Quickly I will write. So here this is this will represent probability, the sum of this will represent probability of s0, that is nothing but 6 alpha. This is also 6 alpha, 6 alpha, 6 alpha, and here probability of r0, that is also 6 alpha, that is 1 by 4, is nothing but 1 by 4, 1 by 4, 1 by 4, 1 by 4, and probability of y equal to r0 x0, it would be p00, 0 0. So this will be the term, that is 3 alpha divided by probability x equal to s0, s0, that is 6 alpha. So this cancel, that is. Similarly, probability of y equal to r1 given s x equal to s naught would be probability y equal to r1 and x0, that is the uh, r1, r1, r1 and s0. So it would be, next would be alpha divided by p of x0, x equal to 0, that is 6 alpha. So it would be 1 by 6. Similarly, this is alpha, this is also alpha. So I can directly write probability of y equal to r2 given x equal to s naught would be equal to probability of y given r3, y equal to r3 given x equal to s naught would be 1 by 6. This is clear. So you will get, what you will get now, you will get h of y given x equal to s naught only. Okay, because you have calculated probability first one, that is j equal to 0 to n minus 1 corresponding to si equal to 0, we have calculated. So directly these probabilities I will sum, that will be 1 by 2 into 1 log 2 plus 1 by 6 into 3 times. That will be, these are 3, 1 2 3. So it would be half, it would be cancelled out, plus log 2 of 6. Clear? Or one shorthand representation also we have seen in the class, h of, these four symbols are there, so h of half, directly we can write 1 by 6, 1 by 6 and 1 by 6. Representation for entropy related to these probabilities, that is the half, 1 by 6, 1 by 6 and 1. Similarly, we have to calculate, this is the first symbol corresponding to condition on S0, we have calculated the entropy. Now all the symbols are remaining, other symbols are remaining. Let's say I equal to 0 to m minus 1, that is 3. So x equal to S0 we have already calculated. Now we have to calculate for I equal to 1, 2, 3. Similarly for others also. So now one more I am writing, and directly I will write for others. So h of y given x equal to s1 would be, similarly j sigma p of y equal to rj given x equal to s1 log 2 of 1 by probability that y equal to rj given x equal to s1 corresponding to s1, that is j alone. So for corresponding to s1, it would be, now the probabilities would be probability that previously we have written r0 x0. Now here y equal to r0 given x equal to s1 would be probability y equal to r0 comma x1 divided by probability x equal to s1. Corresponding to s1 we are calculating. Now first term, that is alpha divided by probability of s1, that is the sum across this one. This is the probability of s1. This probability of s1 would be 6 alpha. That is 6 alpha. That is 1 by 6. Similarly for others, similarly I'm writing y equal to r1 corresponding to s equal to s1 equal to that is nothing but 3 alpha divided by 6 alpha, that is half, and equal to, it will not be equal to, that would be y equal to r2. R2 is alpha alpha, that is same. So x equal to s1 equal to probability y equal to r3 given x equal to s1, that is nothing but alpha divided by 6 alpha is 1 by 6. So h of y given x equal to s1, directly I am writing h of functional form 1 by 6 comma 1 by 2 comma 1 by 6 comma 1 by 6. Now you can also see that these are the same. The previous one, the order is different, but if you calculate the probability, it would be coming as same only, half plus half log to 6. Half plus half log 2 of 6. Similarly, we can see that all the symbols are same only, alpha, alpha, 3 alpha, 3 alpha, alpha, and probability of S2 is also same to S3, S1, S2, S3, that is nothing but 6 alpha, that is nothing but 1 by 4 only, na? 1 by 24, so 1 by 6 alpha, same. Okay, so I urge you to calculate for the other one, that is y by x equal to S2, and solve for y equal to S3. I am directly writing. Now it would be half plus half log 2 of 6, half plus half log 2 of 6. Now we can apply the final formula y of x1, this formula, so which is nothing but sigma I equal to 0, or m minus 1 probability of x equal to si h of y of x equal to si, which we have calculated. So all are same, and probability of xi is also same, that is nothing but probability of x equal to si, that is 6 alpha, or 6 alpha is nothing but 1 by 4. So it would be 1 by 4 into probability of s of I. Let's say 0 is we are taking s of 0. So this will be 0, so 0 will be 1 by 6 only. So 1 by 6 into 4 times would be, sorry, I think wrong. Yes, 1 by 4, the probability is 1 by 4, and the entropy we have calculated as half plus half log 2 of 6 into 4 times. Clear? So it would be coming as half plus half log 2 of 6, or we can further simplify this. That is half plus half log 2 of 6. We can simplify 3 into 2. So half plus half log 2 of 3 plus half log 2 of 2. This would be 1, and it would be, sorry, 1. Sorry, this would be 1. Half plus half is 1 plus half log 2 of nothing but y by x. Now in the next class, I will show you how to calculate this using some property. Okay, and we will also see h of x given y. Okay, so time is over. Now, any doubt in this one? This is somewhat lengthy, but in the next tutorial, we will see how to calculate directly with using some property. Clear? Okay, yes, any doubt in this one? I will revise once again. So the formula, the main formula for the condition probability is this one, the probability of x equal to Si multiplied with the entropy. This is entropy, remember. The previous formulas there were the log function, but here it is entropy. Entropy corresponding to each Si. Okay, and to calculate this one, we have expanded this formula where it is the previous one, the probability is written here and probability is also written here. But to calculate these probabilities from the table, you have to use some identities of conditional probability. You have to apply the concept of conditional probability, which is nothing but probability. You have to use this one, probability of A given B, which is equal to probability of A comma B divided by probability of B. Clear? So you will apply this one and calculate each of the probabilities, and corresponding to that you will calculate the entropies corresponding to each value of Si, each value of Si, that is S0, S1, S2, S3, and you will get four entropies corresponding to four symbols. Okay, like this one. If there are four symbols, you will get four entropies and four probabilities. You will multiply and you will get your answer. Now I will urge you to calculate h of x given y. Okay, h of x given y. Clear? So I think the time is over. So if you don't have any doubt, so you can leave the class. Okay. Yes. Thank you, everyone. Yes. Any doubt? Once again, if yeah, they're in doubt. Okay. Thank you.